Hello, today we will learn about scatter plots and the line of best fit. Now I've got a set of data and it's about, uh, let me highlight it. So the 1 hour record is the farthest distance traveled by a bicycle in 1 hour. The table below shows the world record, distances and the dates they were accomplished. Excuse me. So it's from 1996 all the way to 2009, and this is the distance covered in different years. Now, if you look at the difference between 1996 and 1998, it's a difference of 2 years plus 2. And if you look at the difference between 1998 and 1999, it's a difference of just 1 year. And then from 1999 to 2002, we have a difference of plus 3 years. Now let's see the difference between the distance traveled between in 1998 and 1996. So 79.16, we're going to take away 78.04. So the gap is, the difference is, there is an increase of plus 1.12. Now let us look at the difference between 1999 and 1998. So it is 81.16 and 79.14. So the gap is, there is an increase of plus 2.02. So when I look at this data, it's not linear. You know, for linear, it's really important that there should be a constant change on both sides. If there is a change of like plus 2 plus 1, it's not constant, it's different. Constant will be when there is a change of plus 2, there is a change of plus 2, and the change of plus 2 is throughout, then it will be constant. But the constant change needs to be on the distance traveled as well. So in this case, it's not, because it's a gap of difference of 1.12, then it's a difference of 2.02. If it was a difference of 1.12 throughout, it would have been a linear function, or and when you plot such data, you will get a straight line. But in this case, you will get a scatter plot. Just okay. So a scatter plot is, so this is the graph. So the graph is given. I'll just change the color. So this is x-axis, and this, I'm going to change the color for y-axis. This one is y-axis. So x-axis is always independent variable. So time always goes on x-axis, okay? Because time will bring the change, and it is from and it says years after 1990. So this 0 is 1990. Let me change the color to red. So 0 represents 1990. This is 1995, and this is 2000, and this is 2005, and it's 2020. Okay. Now in graphing, the most important thing is the increment has to be the same. So that's what I mean. So from like 0 to 5, then 10, there is a difference of plus 5. It has to be like this. On y-axis, they're starting from 76, because our starting data here is 78.04, so that's okay. And the difference is not huge, 78 to all the way to 78 to 90.60. That is why we do not need a huge increment. So the increment is really small. They are maintaining an increment of plus 2. So start with 76, 78, and it goes all the way to 92. Okay. So once you have set up your x-axis and y-axis, then you will plot the points. Okay. So I'm going to change the color to, let's change it to this. So this is this point is for 1996, for 1998, 1999, this is for 2002, this is for 2003, this is for 2004, this is for 2007, this is for 2008, this is for 2009. If you look at the data is not in a straight line, but there is when we see the trend, it's linear. It's not in a straight line, but we can draw a straight line through it, and you see the red line that goes through it. So I'm going to change it a little different. So this straight line, so this is called a line of best fit. We'll just draw a straight line through the data that estimates the trend in the data. Okay, now what we will do with this data is, with this line of best fit, I'll just erase, we are going to find the equation for this line. Okay, so usually for linear functions, or to create linear equation, our standard equation is y equals mx plus b. Okay, so b is the y-intercept, so b is the y-intercept, and you know what a y-intercept is. Okay, so y-intercept is the point at which the graph intersects the y-axis. So if this is a graph, so this will be the y-intercept. Okay, now this m is the slope, and there is a formula for a slope. It is m equals y2 minus y1 over x2 minus x1. Okay, first we will find the slope for this line. For the slope of this line, I have to choose 2 points. I'll choose 2 points that touch our line of best fit, that touches our line of best fit. So what I can see is my one point can be this one. So that is the first point, which is the 1996, this one. So this will, so let me write it. So 1996, that will be 6 years after 1990, so x6, and it will be 78.04. Okay, I'm going to choose another point. So this is my, I change this, looks like this is another point that touches the line, and that is that will be 2003. Okay, so this is 95. Yeah, that's 2003. So 2003. So 13. So 10, 11, 12, 13. So the x value will be 13 right here. This is 11, 12, 13, and y will be, so for 2003 is 83.72. Okay, so I have my points, and now I will plug it into my equation for slope, and we'll find the slope for this line of best fit. Okay, I'll write my equation again. 2 minus y1 over x2 minus x1. What I usually do is, let me change the color to black. So let's say if this is x1, this will be y1, if this 13 is x2, this will be y2. Now we're going to plug it in, change back to red. So my y2 is this. So y2 is 83.72, take away, and y1 is 78.04. I'm going to divide by x2 is 13, take away, and x1 is 6. Okay, so I'll scroll down. Say 83.72 minus 78.04. We are going to get 5.68, and we are going to divide by 13 minus 6, excuse me, so that will be 7. So 5.68 divided by 7 will get 0.811. So this is our slope, this is our m value. We'll plug it into our equation. So our main equation is, excuse me, I'm going to erase this. Our main equation is y equals mx plus b. Now we have the m value, which is 0.811, and that's x plus b. We need to find the y-intercept. We need to find this value. This b is the y-intercept. We need to find that. To find this, we need the another ordered pair, or the coordinates of another point. So what I'll do is, I'm going to choose the point that I will choose is change the color to black. I will choose this point. Let's say, or I'll choose this point because this is touching the line as well. You know, there is a slight touch, which is okay, and that will be of 2004. Okay, so it will be 14. The x value will be 14. I'm going to change it back. So right here, the x value is 14, and y is 84.22. So I'll need these 2 points, 14, 84.22. I'll write it to the side. I just want to confirm it, 1484.22. Now I'll plug it in. So always remember, I'll change this color to black. Like, say this is x1, or I shouldn't say x1, this is x, and this is y. The first value is always on x-axis, and the second one is on y-axis. Okay, it's a convention. Excuse me. So I'm going to change it to red. I will replace this y with 84.22, 0.811x. So what I will do is, I'm going to substitute that x with 14 plus b, because b is our unknown. I'm going to scroll up. 0.811 times 14, we will get 11.354 plus b. We'll take away 11.354 excuse me, from both sides. So it cancels. So 84.22 take away 11.354, we'll be left with 72.866. That's our value of b. So our entire equation will look like y equals what is our m value? Excuse me, it is 0.811x plus 72.866. So this will be our equation for this line of best fit. Okay, so 0.811x plus 72.866. Okay, so this is what we have. So this is for this data. Okay, now so these are the things you need to remember, and this is how you will find equation for the line of best fit. Thank you very much and have a good day.